Bismillahirrahmanirrahim. Dear students, this week we will perform impact test, and here is the Charpy's impact testing machine that we will use for the performance of this experiment. And we will be performing this experiment for two types of specimens. One is for bending and the other is for tension. First we will perform the experiment for the bending case, and in this apparatus we have a hammer. Give you a close-up look. Dr. Rizwan, would you please help us pointing out the hammer? So this part is a hammer. Its mass is known. We will let you know how much is this mass. And we have a lever on the other side with the help of which we can uplift this hammer. This hammer achieves certain elevation, and once that elevation is achieved, automatically the hammer is released and it has a free rotation. We have a scale here on this machine that is graduated in terms of degrees, and it goes from 0 degree up to 170 degrees. So each time we will be noting down that how much is the value of rotation of this hammer. So I think in the first case, like when we will be performing it for bend, first case we will give a free rotation. So let's do that. So Dr. Rizwan is helping us for that, and he's rotating the lever and the hammer is going up. Once the hammer will achieve certain height, this part, let me give you a close up here, this red part will collide with this part and the hammer will be released, and we will note down that how much is the value of angle on the scale. You see the red part is approaching that lock part, and here we go, the hammer is released. Now the hammer is rotating and the needle of this scale has certain value. It's not very clear in
151
view. Try to get you a closer look.
Yes, we have over here 140, and this is 150, and this is 160. So this is basically one division after 150. So this is 151 degrees.
All right. So in this free rotation case, the value of angle is 151 degrees. Now we will wait for a while till this hammer comes to rest position, and then we will put the specimen for bend test in the machine. Here is the specimen for bend test. It's a small specimen. It has a groove in it. This groove is provided to generate a predefined failure plane so that it fails from this location. And now we will put this specimen in the path of the hammer. And next time when the hammer will rotate, the hammer will break this part and some of the energy will be absorbed by this specimen. So next time we expect a smaller angle value as compared to this angle. Let's see, what do we get? So we have clamped the hammer. We are lifting it up. Dr. Rizwan would place the specimen in the path of the hammer. Okay, let me give you a closer look. So here is the specimen placed in the path of hammer. Now when we will rotate the hammer again and the hammer will be released, this hammer will collide with the specimen, and it will break the specimen into two parts, and we will note down the angle value for that case as well. So let's do that. Yes, Dr. Rizwan, please go ahead. And we are adjusting the 0 on the scale. Now we are lifting the hammer again. The elevation of hammer is fixed because it gets released automatically. Now we are close to that point, and okay, actually we have to be a bit careful because once the specimen fails, it kind of travels at a fast speed. So now we can see that the specimen is broken, and let's see the angle value. Okay, so if we look at the angle value, last time the angle was about 151 and this time I think it's
130.
it's 139. So if you
One
guys
degree
can see
before
that.
140.
Right, so this time the angle value is smaller because some of the energy was absorbed by the specimen. That's why the hammer achieved less height in this case, and the angle is smaller. And here is the failed specimen, as we discussed earlier, that the specimen will be broken into two pieces. So it is broken. So this completes our performance for the impact test under bending. Now our next video will be related to impact test under tension. So we'll make a separate clip for that. Thank you very much.